Alright, so we're going to do the first problem. I realize this is a lot of review, but that is what this unit has in it. So, here we go. Number one, a rightward force of 302 newtons is applied to a 28.6 kilogram crate. It accelerates across the floor at a coefficient of friction, which this essentially just means drag. So if I'm moving my pen across the table, that resistance is its coefficient of friction. It's its drag. Between the crate and the floor of 0.750, determine the acceleration. So let's talk about what we know. We know that the overall force is mass times acceleration. We know that the overall force is equal to mass times acceleration, right? So the overall force is the applied force minus the force of friction, and that equals mass times acceleration. Let's look at what we have. We have the mass. Bam. We have the applied force. Bam. We're going to figure out the force of friction, because the force of friction is going to be the force of gravity, gravity's pull on this object, times this friction coefficient, which we're going to do that in a second. Let's start by making our diagram. And I've already sort of made this, so let's talk about everything that we did, right? So, this is our crate, right? We know the force of gravity is our mass times gravity. So, pro tip, if any object is sitting on the ground or the floor or whatever, it's just mass times Earth's gravity, which we know is 9.8. Okay, so mass, 28.6 kilograms times Earth's gravity is 9.8. That is going to be our force of gravity, which I believe comes out to 280.28 or something. So, our applied force, 302 newtons. Our normal force, since our object is moving, our normal force is going to equal the force of gravity. So we know it's going to be the same. And then our force of friction, which we're going to find. So let's line up our forces, okay? So, first force we have is the force of gravity, 280.28, okay? And how I found that out is I did mass times Earth's gravity, since it said it was on the floor, right? Next force we have is the normal force. We know in an object that's moving, the normal force, moving on the x-axis, the normal force will equal the force of gravity, so we know that this number will be up here too. And then finally, we have the force of friction, which what we said before was the coefficient of friction, which is what? 0.750. And we're going to multiply that by force of gravity, which is 280.28. Okay? So, you should get, hopefully we can see this, about 210, something like that. So that is going to be our force of friction, 210. So now we have everything we need to solve this problem. We have our applied force, which is what, 302, right there. We have our force of friction, so we're going to minus 210. We know that equals our mass, which our mass is 28.6, times our acceleration, which is what we're trying to find. We'll just put that in parentheses. And our overall, what should we get? We minus this. Let's see, 302. That's not a point. That's just 302 minus 210. Let's see if I can do that in my head. 92. And then now we got to divide this out. Since it's multiplying here, we do divided by 28.6, divided by 28.6. And our answer, we're going to go right up here. Hopefully you got 3.22 meters per second. Cool. So, I think it's squared too. Is it squared? No. Yeah, it is squared. So, there we go. That is our deal. We did number one. Not too bad. All you got to do is remember your basic formulas. So these right here, if you remember that, then you just sort of systematically plug things in, figure out, plug in, And then it's just a basic, like almost pretty much Algebra 1 problem. Super simple, super easy. I'll make another video and we'll do the next one.